This video is going to cover Chapter 10, Triangle Trigonometry, and we are now going to look at oblique triangles. We're moving away from right triangles into oblique triangles. So let's define what an oblique triangle is. It's any triangle basically that's not a right triangle, and so it doesn't have the 90 degree doesn't have 90 degrees in there. And so there are two types of oblique triangles. There is the acute and there is the obtuse. And just like with angles, you can imagine that these triangles are representative of that. And so in an acute triangle, all the angles are going to be less than 90 degrees. However, they will all add up to, remember, 180 degrees on inside of the triangle. That will be important for being able to solve any of these triangles later. An obtuse triangle has one angle that is greater than 90 degrees. And so one of the things I want you to notice is that the angles are all labeled as capital A, B, and C. And the sides are labeled as lowercase a, b, and c. And so we'll use this naming protocol throughout the videos. So this video is just to introduce you to how to solve oblique triangles. And so we're going to look at is a triangle a right triangle? In this case, it is not. So we are not going to do any of the right triangle formulas using this, at least to start off with. And so when we're trying to figure out how to solve the problem. Not to say that we might not use a trig ratio after we've got the problem started, but you'll see that, and that's really more in using the cosine rule. So not to jump ahead of ourselves, but let's make sure we're following the path. So is the triangle a right triangle? No, it's not. So let's ask, do we know a side and its opposite side? If we do, then we're going to use the sine rule. And that's what I want to introduce in this video of what is the sine rule. We will come back later on to the cosine rule, but that'll be in the last couple videos of this chapter. So using the sine rule, we're going to use the law of sines. And so the law of sines states that the lengths of the sides of the triangle are proportional to the sides of the corresponding angles. So that means that sine A, so the sine for sine A here for that angle is, and the ratio to side A is equal to the sine of B and its and the opposite side B, and the sine C is equal to the ratio of the opposite side C. And so they're all equal to each other. And since they're set equal to each other, as long as we know three of these values, then we can go ahead and solve a problem using the law of sines. And so in solving the oblique triangle, what it means to solve the triangle is basically figure everything out. We want to figure out all the angles. We want to figure out all the sides. And so to do this, we want to make sure that we look at the type of triangle it is. There's two cases. There's actually four cases, but we'll look at two cases here. Case one is when two angles and a side are known. And so when we know two angles, so an angle and a side, and we know that when those are known. And when we have case two is when there are two sides and an angle opposite them are known. And so case two is when we know two sides and an angle opposite them is known. Angle opposite of one of them is known. So notice in case one and case two, and this is going to be important as we look, because this will you're going to need a question if is it case 1 or is it case 2. Is it case 1, 2 angles and a side? Or is it case 2, 2 sides and an angle? So that's your key right there. 2 angles or 2 sides. And then is it 2 angles and a side or 2 sides and an angle? So make sure that you got that. Write it down in your notes for the test if you need to. And there's some other things that you'll need to make sure that you're familiar with as we're going to solve these oblique triangle problems. One thing really important, make sure that since you are not working with a right triangle, that you do not try to use the Pythagorean theorem. Okay, it only works on right triangles, not on oblique triangles.